Hello and welcome to this Bitwise webinar on the latest updates to Hydrograph, the ETL development tool designed for the big data ecosystem. My name is Nathan Nichols, and joining me today is our very own Pushpinder Garg. As a senior technical architect here at Bitwise, Pushpinder played a key role in architecting the Hydrograph project. He's a leading member of the Bitwise Design and Architecture Team, or DART, where he's responsible for driving innovations in big data, cloud computing, blockchain, and microservices. Before I pass things over to Pushpinder, let me first provide a quick introduction to Bitwise. Bitwise, a data management, consulting, and services company, uses over 20 years of enterprise data management experience to help bridge gaps between traditional EDW and cutting-edge technologies, including big data and cloud. What truly sets Bitwise apart is our technology leadership in creating unique accelerators that reduce the time, complexity, and cost of large-scale data initiatives such as ETL conversion and cloud migration. If you have any questions during our session, feel free to send those via the question feature or contact us at any time at sales@bitwiseglobal.com. And with that, I'd like to pass things over to Pushpinder. Pushpinder?
Thanks, Nathan. Welcome, everyone. So let me start with the challenges that industry is facing regarding the data processing tools. So speaking of the volume, there is exponential growth in data volumes, and it is expected that this exponential growth will continue in future as well. Whereas traditional ETL tools are not able to scale to match up these exponential data volume. Traditional ETL tools are still vertically scalable, and at after some point, you cannot scale them to the larger volumes. The other challenge is the pattern that is emerging is ephemeral compute. So what it means is that you go with some platform as service or a serverless environment where you spin up compute on demand whenever you need and of whatever capacity you need. And then once your data processing is done, you shut it down. This is very important for cost optimization, especially in cloud environments, whereas traditional ETL tools, they do not support the on-demand compute environment that well because either of their licensing structure, either it is user-based or core-based, or the setup environment is so difficult that it's not easy for a on-demand environment to set up the traditional ETLs. Then the third one is the technology landscape, where the technology landscape is changing very fast. So earlier there were traditional ETL tools with GUI which used to run on their specific engines, and then came open source coding based tools like MapReduce, Pick, and Hive, and then later on came Spark version 1 with RDD, and then version 2 with data frame SQL. So the tools are changing very fast, and even if the tool is same, you might find the APIs are changing, their versions is changing, and you find your developers spending more time in learning these new tools and technologies instead of enhancing your business, instead of enhancing your business logic. Um, you find your developers struggling with keeping up with the changes in the technology. So that's the another challenge. And the last challenge that I want to talk about is the migration. So whenever there is a new technology that you want to adapt, um, it's not that flexible. You have to spend huge amounts of efforts in migrating from one technology to another technology. Even though your business logic, underlying business logic is the same, the job that you want to perform is going to do the same process, but you have to rewrite your code, and that's the biggest roadblock to migrate to any newer technology. So those are the main challenges that are being faced by the industry for regarding their data processing tool. Then coming on to why Hydrograph and where Hydrograph can help. So Hydrograph um has three main properties. One is that it's a GUI-based development tool. Another one is that it is big data and cloud. It runs on big data and cloud. The third one is that it's open source and economical. So if we compare Hydrograph, which is a GUI-based tool, with a scripting or a code-based tool like PySpark, there are advantages like you can leverage your existing developers who are well versed and who are used to working with a GUI-based tool with a shallow learning curve. Um, they can they can start working on Hydrograph, and you can still adapt the modern architecture. Then, in terms of development effort, as per the benchmarking done by our clients, developing complex workflows is twice as fast on drag drop UI compared to coding. And that's because you've got feature rich components. You can just provide the parameters to those components. It's easier to manipulate graphs in a GUI based environment, it's easier to work with. So overall development time is reduced to half. Now, one of the problem with coding based platform is the API changes, version changes, um, where you've got tens and thousands of jobs, and if version change, then you need to touch all those jobs. You need to make code changes in all those jobs, and you need to test all those jobs, and that's a huge effort. Um, Whereas Hydrograph being a GUI-based tool, it captures business logic in a descriptive form in the XML. So if API version changes, all you need to do is you upgrade the engine, and you don't have to touch any of your job, any of your existing jobs. They all remain unchanged. So that is one of the advantage with the GUI-based tool. And then overall, it has a less maintenance effort. Um, it's easier to understand a job in a GUI-based environment. It's easier to make changes in the existing job. You can do things like lineage analysis and impact analysis with these tools. So overall, it is easier maintenance compared to a coding-based tool like PySpark directly. Then comparing big data and cloud-based tool with traditional ETL tools. So here, Hydrograph can support platform as service environments like EMR on AWS or Dataproc on GCP, or it can support infrastructure and service environments on on private or hybrid cloud like Cloudera or Mapr, and it can also support serverless environments like Glue. So what it means is basically you can run it on public cloud, you can run it on private cloud, on-premise, hybrid cloud, and multi-cloud environments. So it can support best of breed of your architecture. The other advantage with big data is that it's horizontally scalable. So as data volume increases, you can just go with more nodes, more number of nodes, and it's going to scale horizontally. Uh, Another advantage is that it's fault tolerant and distributed. So if any node goes down when it is running, it's basically shifts the compute to a different node, and that's all is transparent to you, and it automatically handles these kind of failures automatically. And then it supports all kind of workloads. So it supports batch, streaming, and it also supports ad hoc workloads. For example, data preparation, feature engineering, machine learning kind of ad hoc workflows. Those are also supported uh, in Big Data and Spark. Then comparing it with the traditional ETL tools, so Hydrograph is open source. The business logic that is captured in XML, that is also open source, and there is no core or user-based licensing, so there is no lock-in. Uh, you can do customizations in Hydrograph, so you can integrate Hydrograph with your existing metadata tools. You can create your own components easily. You can create your own functions easily. You can integrate it with the catalog tools. So being open source, most of the things are API driven, and you can easily integrate with your existing tool set. So these are the main advantages of Hydrograph. Now, going into Hydrograph architecture, to just give you a quick overview of the Hydrograph architecture. So, Hydrograph has a developer UI, which is a desktop-based application. It's a drag-drop UI where user creates a job workflow, and when user creates a workflow, it internally captures all the business logic in a descriptive XML, and that XML acts as a job artifact. Then there is an execution service which basically parses the XML and executes that logic in the underlying engine. On the source and the target sites, we can see it supports all major RDBMSs. It supports cloud uh, data sources and targets like Redshift, Snowflake, BigQuery. It also supports NoSQL databases like MongoDB, HBase, and Cassandra. And each of these components is pluggable. So you can add your own components. If you want to add a component, just drop a folder and restart your app, and your component will be added into the palette. And users can create their own custom components. On the engine side, the engine is also pluggable. So we have support for Spark, Flink, Taze, Glue, and new engines can also be added in future easily. Um, so because we support Spark, so we can execute jobs in multiple environments. We can execute jobs in AWS, EMR, in Azure, HD Insight, GCP Dataproc, and you can also execute it in hybrid cloud environments like Mesosphere, or you can execute on-premise or a private cloud environment on Cloudera or Mapr. On cloud, it also supports native services for logging and monitoring, like CloudWatch and Stackdriver. Then moving on to the Hydrograph infrastructure components. So, like I said, there is a desktop UI with which user or developers interact to create their job workflows, and the that we call it as Hydrograph IDE, and that IDE has integration with any Git-based version control, so users can check in, check out their jobs through any Git-based version control, and Hydrograph IDE also creates automatically a Maven build file through which you can set up your CI/CD using tools like Jenkins. Jobs are deployed on edge node or any distributed file system like S3, and then from there, execution engine picks those job artifacts and then executes them on the underlying fabric. And the underlying fabric can be any of like MapReduce, Flink, Spark, Glue. Now, coming on to the new features that we have added in Hydrograph. So, in terms of new usability features that we have added, so um, like I said, that pluggable user interface. So all the components are now pluggable. So you don't need to upgrade your entire build of Hydrograph in order to add a new component. All you have to do is just drop a folder and restart your app, and you will see that new component in your palette box. Then enhancements in your expression, um, inline expressions, where you can provide your test input values when you're writing the expression, and you can see your expected output. So you don't have to run the job in order to test your expressions. You can do that right into your expression editor, where you can just provide multiple input test values and see if your expression is giving you the expected output or not. Then we have added lots of new components, and specifically cloud sources and targets like Snowflake, BigQuery, Kinesis, PubSub. So it means that you can now integrate your on-prem data sources like RDBMS or other cloud data sources, transform your data on big data environment, and directly load your warehouse like Snowflake. So there is a direct connectivity uh, available from Hydrograph to all these cloud-based data targets or sources. Then we already had a metadata and lineage API. Now we have also added a support for Apache Atlas out of the box. So whatever lineage that is captured, you can see that lineage in Apache Atlas UI. And we have also added support for glue catalog, so Hydrograph can pull the metadata information or update the metadata information directly in glue catalog. Then a few debugging features we have added, like view data, so you can now see data flowing through any link, any intermediate data. uh, so you can just click on the link and say view data, and then you will see the data that is flowing, and that will help you in debugging if something is going wrong. And we have also added advanced logging features where we integrate with Stackdriver and CloudWatch. Then another main feature that we have added is the streaming support. So now we have added support for Spark structured streaming. So what it means is that you can express your batch as well as streaming workflows using the same drag and drop UI. We have added support for sources and targets like Kafka, PubSub, Kinesis, file-based sources like Mixscheme, fixed width, and also we've added support for transforms like group combine, windowing, filter, aggregate. So now you can write your streaming data workflows as well using Hydrograph, and all the standard batch features like the execution tracking, view data, parameterization, metadata API, those are all available in streaming as well. Then we've added the integration with Glue. So Glue is basically a script-based serverless ETL platform on AWS. Uh, so Hydrograph can act as a UI on top of Glue. So um, when you develop a job in Hydrograph, you can just say that I want to run this job on Glue, or I want to run this on EMR, or I want to run this on my local, or I want to run this on on-prem Spark cluster. So with Glue integration, we have also added support for Glue catalog, which means it automatically fetches metadata from the catalog, and you can also update the metadata of uh, of the Glue catalog using Hydrograph UI. And from UI itself, you can deploy Glue jobs, and you can specify the schedule, whether it is time-based or a trigger-based, while deploying Glue jobs. And some of the components which are not present with Glue, native Glue, like the episodic component, mainframe components, fixed width, mixed scheme, those components are also available with Hydrograph Glue integration. And it ships logs to Amazon CloudWatch. This is the overall flow of the Amazon Glue integration, where Hydrograph can be used as a UI on top of Glue. Then we also supports uh, native EMR. So here, Hydrograph jobs run on EMR Spark environment. So the way it works is that Hydrograph deployable stays on S3, all the artifacts stays on S3, and the Hydrograph executable engine also stays on S3. And we have scripts to uh, spin up the cluster on demand, and then run those jobs, run the Hydrograph jobs on EMR and shut down the cluster when the jobs are done. And you can integrate your on-premise data sources or your cloud data sources, transform them using EMR Spark environment, and then load your cloud targets. And we integrate with CloudWatch for log login shipping logs. And similarly, we have integration with the GCP Dataproc. So that integration is pretty much similar to EMR. Here we use Dataproc Spark environment to execute Hydrograph jobs, and the deployable sits in on GCS. And again, here we have got scripts to spin up the cluster and tear down the cluster on need basis. And here we integrate with the stack driver for the log. Um, so that's it for the um, uh, introduction. Now we'll just look at a quick demo of Hydrograph. So this is the Hydrograph UI. On the left, you can see the palettes. These are the components which are available on the palettes, and then some of the transform components, operation components. On the right side, you can see the canvas, job canvas. This is the project explorer on the left, where you can see the jobs listed over there, and you can select any job and you can open that job in the job editor. And then you can see the flow of the job. You can see the source and target. Here we've got one Excel and then one uh, SQL source is there. And this is the component properties window. So here is Excel, so it has got Excel specific properties. Then this is the transform. This is where we can specify the expression, the input fields, output fields, and the expressions. And we can go to the expression editor, and here is the expression editor, and we can see the functions which are available. There are lots of functions available. You can add your own functions. Here you can validate the expression. So you can specify some dummy inputs, and you can test those expressions. So here you can specify the inputs, and you can evaluate those expressions uh, in line itself. Then we've got these watch points. So basically, you can view data after the job is executed. So you can add watch point. Once the watch point is added, it turns red. You can see different modes of execution. So you can say that, okay, I want to run it in glue mode, local mode, or remote mode. Here we're going to run it in local mode. Um, this is just the configuration. And then uh, once the job is executing, we can see the tick blue box is the execution tracking, where all the components which are completed are ticked. We can see the number of records on the links that have been passed through it. And here is the job log. So this one is the detailed job log, and there we can see component level summary. We see each component, how many records processed, uh, on which port, and then we can see job level summary, that how many batches were there and how much time it took to process each batch, and what was the status of the each batch. And then this is user-friendly grid log. This is specific for the ETL user. It doesn't have anything specific for Spark. You can apply filter and all and see specific messages on this grid console. And then we can also view data, like I said. So we had added a watch point. Now we can now view data on this console, and we can see intermediate data that is passing through each link. And here again we can apply filter, and um, we can see exactly which data is passing through it, and that helps in debugging. So that's all for the quick demo. So in summary, Hydrograph delivers a lot of value. It is economical and yet effective data processing tool. It gives you flexibility to choose best engine, whether it is on cloud, on-prem, or in hybrid environments. And it also allows you to adapt and change to modern technologies without migrating your business logic and without migrating your jobs. So that's all from my side. Nathan, over to you now.
Great, thanks, Pushpender. Good stuff. So we hope that this session gave you a good understanding of Hydrograph and the latest updates to the tool. There's a few easy ways to get started. First, you can visit our website, bitwiseglobal.com. There's Hydrograph resources available there. Also, we invite you to download the open source version of Hydrograph available at our GitHub page. The link's there on the screen. And then the fastest and easiest way to get started is to plan a POC supported by our experts. And to start that, feel free to contact Bitwise at sales@bitwiseglobal.com. And with that, we'd like to thank you for your time. Thank you for joining us today. We look forward to talking to you soon.